Okay, start from Suresh. A very good evening to all of you. All the ATAL online FDP participants. Today is the second day. Session 3 and session 4 will be taken today. Session 3 will deals with the government policies and incentives for EV adoption. And session 4 will deals with recent advancement in battery. There's a small change in the schedule. Session 3 will dealt by the Dr. Arul Selvan. Since the former Vice Chancellor and senior most professor of Anna University Wales in another official occupation, this small change has been occurred. And a small instruction to all the ATAL FDP participants, please be in the online throughout the program. That is 6 p.m. to 9 p.m. 6 to 7:30 session 3, 7:30 to 9 session 4. At the end of the session 4, that is by 9 p.m., the attendance cum feedback form link will be posted. Day 2. It's a different one for every day. So you are requested to put your attendance and feedback form through Google. Then only it will be counted for calculating the attendance purpose. You also requested to give your valuable feedback about the expert speaker. And I understand that all the learned colleagues will extend utmost cooperation to conduct this ATAL FDP in a successful manner. At this juncture, we thank and congratulate the AICTE for selecting our proposal and grant permission to conduct this 6 long days online ATAL FDP. We also thank our management, particularly our Secretary Sri Srikant Sir, for providing necessary support, infrastructure, facility, and guidelines for this ATAL FDP. We thank all the persons, those who have joined in online, and also extended the various logistic supports for successful conduction of this 6 days online FDP, either by directly or by indirectly. All the recorded videos will be uploaded as per the ATAL FDP guidelines, and it will be made visible to all the participants. With this small instructions, let us move on to welcome Dr. V. Arul Selvan from NIT Trichy. Dr. Arul sir. Dr. Arul sir.
Good evening, Dr. S.V. Saravanan sir.
Good evening, Professor. We welcome you for this ATAL FDP online program as an expert speaker of today. Dr. V. Arul Selvan, serving as a professor at National Institute of Technology, that is NIT in India, in the Department of Mechanical Engineering. And Professor Dr. V. Arul Selvan had his BE Mechanical Engineering degree in 1993 at Bardiyar University. Later, he got the MTech Energy Engineering in the same institute where he is working, NIT. Formerly, it is called as Regional Engineering College, Tiruchirappalli, which was affiliated to Bardiyar University then. And also, he has got the highest academic degree of PhD in Mechanical Engineering in NIT Tiruchirappalli. Coming to his experience, as on today, Dr. V. Arul Selvan, Professor NIT Trichy, Department of Mechanical Engineering, is having teaching and research experience 28 years. He has published over 100 research articles in leading international journals and conferences. He is an active reviewer for the international journals such as Energy, Applied Energy from elsewhere publications, Energy and Fuels, ACS, American Chemical Society, Chemical Engineering, Communications from Taylor and Francis, publications, a Journal of Petroleum Technology and Alternative Fuels from Academic Journal publications. He has produced 7 PhD holders so far, and 10 are in the process right now under his guidance. He has guided more than 54 MTech theses and 38 BTech theses. He has delivered over 50 expert lectures at various engineering colleges and universities in India. He attended more than 30 short-term training programs and organized 8 national-level faculty development program, that is FDPs, for the benefit of teachers of engineering colleges across India. Dr. V. Arul Selvan is nominated as a chairman of SCI India Southern Section Trichy Division. He has filed so far 6 patents on the theme of waste management to intellectual property of India, Government of India. Dr. V. Arul Selvan is the life member of Indian Society of Technical Education and member of Society of Automotive Engineers, that is SCIE India. Based on his technical contributions, his biography was included in the Marie Curie Who is Who in the World in the year 2011. He received Distinguished Alumni Award from Sri Krishna College of Technology, affiliated to Bardiyar University then, where he graduated his BTech. Without taking much of the time, in spite of his busy schedule, we thank on behalf of ATAL FDP AICTE and in our own behalf of Meenakshi Sundararajan Engineering College to deliver his expert lecture on session 3, the government policies and incentives for EV adoption. Professor Dr. Arul Selvan, we welcome you, sir.
Thank you, Professor. Thank you very much for the nice introduction about me. First of all, I thank Dr. S.V. Saran for inviting me to this FTP program. So the topic is very important and interesting at this current scenario. And I am very happy to see the faculty members who are working in the field of mechanical engineering. So you have a very wide variety of scope in the future. Shall I share my screen, Professor?
Yes, Professor, please.
Yeah. Hope you are able to see the screen.
1 minute, Professor. Screen is not viewing.
Oh.
You have shared the first page, sir?
Yeah, first page, yes.
No, sir. Wait, it is not shared so far. Please check, Professor. Yeah, it is viewing. Go to the first slide, Professor.
Yeah.
This is the first slide, right?
Yeah, this is the first slide.
Yes, Professor. Please continue, Professor.
Yeah. So I welcome all of you to this AST sponsored 6 days ATAL online FDP program. And the session 3 is dealing on government policies and incentives for EV adoption. So which is a current topic on automotive sector. So I have a vast experience in the field of teaching, especially in the field of automobile engineering. So I started taking class for the students from the basic pure mechanical systems to the most advanced one, what is available today, with all electronics, sensors, control systems, and all advanced materials. So all the department have worked together, and the automobile is one of the area where all discipline synergize, and we have an advanced product what we call as a modern automobile. So here this EV adoption, we have certain guidelines set by the government worldwide. And now whenever there is a change in the system, like a transportation system is concerned, so we are moving from IC engine powered vehicles into electric vehicles. So the acceptability of the consumer is always difficult, and we have to convince them by giving proper information, giving what are the advantages and benefits of moving towards electric vehicles over the IC engine powered vehicles. So the government has taken a lot of initiative in the recent years for EV adoption, especially in India. So this session, I am going to give an outline of about the electric vehicles, and then what are the policies initiated by the government and the incentives announced by the government for the adoption of the EV. So the electric vehicles are basically the vehicle that operates on an electric motor instead of an IC engines, and powered by batteries in general. And here the reason for moving EVs are mainly the environmental aspects, as the fossil fuels are creating more pollution like CO, CO2, HC, soot and smoke, and NOx. So these are all harmful for environment as well as for the human beings. So this is a major reason why we are moving away from fossil fuel powered vehicles. And another major reason is the availability of fuel, that is estimated about another 20 or 25 years. So it's depleting in a very faster manner. So we have to find an alternatives. So already we have taken alternatives such as the alternative fuels like biodiesel or ethanol have come into picture, and CNG, LNG, hydrogen, LPG. So we are moving away from our traditional fossil fuels, and we are exploring other possibilities where some of the principles are again relying on the engines, IC engines, and we are again working towards completely moving away from IC engines towards the use of electric vehicles with the help of battery and motor. And hydrogen is considered one of the major alternate where this can be used in IC engine, as well as it can also be a source for hydrogen fuel cells. Again, you will be able to produce electricity. So there are many initiatives have taken by researchers and all in progress. So there are many questions are coming. Is charging an EV cheaper than buying gas? Or electric vehicles affordable? And how and where would I charge EV? And what type of EV is the best for me? And will an EV go enough miles between Philips? And should I buy new or used? Or is it better to lease? So many questions are coming to my mind. So this is what the customer is asking this question before moving towards electric vehicles. So initially, when the electric vehicles have come into market, then the major question have come towards the range of the vehicle. So how much distance I can travel with a single charge. So now, with advanced technology and fast charging technologies, then we'll be able to charge about 60% to 80% in half an hour to 1 hour. And we'll be having the range of about 200 to 250 kilometers per charge. So this makes the EV more affordable and more reliable for highway trips. So now many automotive industry, they have come forward with advanced EV, so that it is highly reliable on par with IC engine powered vehicles. Then when it comes to the cost, so this is one of the major question everyone is asking before going for purchase, whether it is cheaper to charge than to fill the tank, and what about the electricity rates, whether it is more stable than gasoline prices, and free or reduced tolls, and maintenance costs are lower, especially with the long battery warranties, and grants and rebates and tax credits for new or used EVs and chargers, and higher upfront cost is typically paid back by about 50,000 miles. So now when cost is coming into picture, today we have two charging options, either charging stations or having quick charging mechanisms where you can charge it, or else even home charging is also possible with the 15 amps plug point. But as far as now the tariffs are concerned, so the government have set certain tariff for household, and once the EVs become popular and more EVs are available at home, then the tariff or the charging or metering system will be different. As far as today, when we consider the electricity cost, and this is more cheaper when you compare the petrol or diesel, but maybe in future the trend may change when the market is moving towards its peak. Then when it comes to the maintenance, so this is a major question by the customer. How about the maintenance of my electric vehicle? So IC engines are having many number of moving components comparing to the electric vehicles. So the maintenance is also relatively easy, and only thing is the cost of the battery is one of the concern as far as today. And automotive manufacturers, they give the warranty of their batteries to about 5 to 7 years. And after that, we have to go for replacement of these batteries. So which will be having the major share when you comparing to the purchase of the vehicle. So say example, if you are buying a vehicle for about 15 lakh, then for 7 years period or 9 years period, you need to go for replacement at the cost of about 7 lakhs or 8 lakhs something. So this kind of things, right? So this will come only at the end of the service life of the batteries. But when you consider the running period, the maintenance are relatively simple and easy because of less moving components are present in EVs. Then when we consider the emissions, so this is one of the major concern, the emissions. So today, what we use the electricity is from. Yeah, Rajkumar, can you put your
mechanical ரொம்ப நல்லா வந்துருக்காங்க. நானே நம்மதெல்லாம் போயிட்டு நானே வருத்தத்துல இருக்கிறேன்.
Admin, can you put
கிட்ட கேக்குறாங்க,
mute for all?
கிட்ட கேக்குறாங்க, அன்புலி மாமா கிட்ட கேக்குறாங்க, இவங்க கிட்ட கேக்குறாங்க, பபியோலா கிட்ட.
Rajkumar sir,
Hello.
Rajkumar sir, can you mute yourself?
Yeah. Admin, please take a note of it. Just maintain the mic mute for all the participants during the presentation. Okay. So I think, is it audible now?
Yes, sir. Yes, sir. Yes, yes.
Okay, thank you. So the lower emissions are claimed because uh, you are comparing with the IC engines. So you burn the fuel, and the fuels, basically the hydrocarbons, once it has been burned, then you convert these hydrocarbons into different gases like CO, CO2, HC, NOx, and smoke. So these are the products of the combustion, which pollutes the environment. Then when it comes to the EVs, there is no combustion takes place. So we call it a clean transport. But now we have to understand, so how do we charge the batteries? As far as if you take the control volume with the EVs, then you can claim it is clean because there is no input and no output, especially when the mass is being concerned. Only the electricity get in, and so no gases or liquids are involved in it. So what we claim is a clean. But when you consider how the electricity has been produced, so major share is taken from the power plants that is run by fossil fuels. And this fossil fuel again further creates environmental pollution, and the load will increase because more and more electric vehicles causes for more energy demand, which causes for more fuel need to be burned, especially when you take coal. More coal need to be burned off in order to produce more power. So ultimately, so the energy, when it comes to the energy, whether you take energy from petroleum fuels and run the IC engine, or you take energy from coal in power plant where you produce electricity and it has been transmitted through transmission lines, and you use it in charging station or at home to charge your battery. So if you take the entire cycle, so this constitutes for again same kind of emissions. So now we have an option. So instead of going with the fossil fuel like coal, you can go with renewable fuels, like you can go with windmills or through solar power plants. Then in such case, then what you claim the lower emissions is really a true lower emissions. Otherwise, the claim what you put forth will not be lower emissions. So the entire world is working towards harnessing energy from the renewable sources so that the lower emissions can be achieved. So this is one of the major tasks. So a lot of infrastructure need to be developed, especially on solar power plants and wind power plants. So here there's a comparison of the conventional fuel and hybrid and plug-in hybrid and battery electric vehicles related to its end of life and use of petrol and diesel, electricity production, petrol production, bioethanol production, vehicle assembly and component production. And this has been compared with the lifetime greenhouse emissions in tons of CO2 emissions. So definitely the battery electric vehicle or giving lesser CO2 emissions. So as far as the EVs are concerned, we have EVs used in many places. It is not new. But today, we are focusing on automobiles, especially for cars. That's why it become more relevant, and more focus is given by the government. As you take an example, the locomotives were being powered by electricity. Electric trains were already there, and golf carts and forklifts were used in industries, and the electric buses and nuclear submarines and elevators. So there, the electricity been used for powering it. And now when we focus on the cars, that's why it gains more attention, because when the cars been concerned, more and more volume of the cars being produced and used by the people. And now, because of the environmental concern and the scarcity of the fossil fuels, we are moving towards electric vehicles. So now, how to change the customer moving from the conventional transportation system of ICE engine powered vehicles into EV. So this is a major challenge. So what kind of EV is right for me? So we have many choices, like the hybrid electric vehicles, or plug-in EVs, or EVs, direct EV systems. So the battery electric vehicles are taking pure batteries, and this is being mounted at the floor of your on the chassis, and power is taken from that to drive this electric motor, and from the motor you connect the transmission system. So the remaining is almost similar to your ICE engine powered vehicle. So the major change is when you retrofit with the ICE engine. So here it been replaced with the electric motor, and instead of this fuel tank, we use batteries. So batteries being charged by electricity. So this is more convenient. It's a simple and low maintenance, because only electric motor is involved. Many choices of vehicles are there on battery electric vehicles. Depends on size, like a compact, hatchback, or sedan kind of thing. So now there are certain questions like the fill-up time. The charging takes more time than filling a gas tank, and charging anxiety. Where we'll find charge stations, and the range anxiety. So can't drive as far between fill-up. So these are major questions coming from the battery electric vehicles, because it is purely operated by battery. So now there were applications, mobile applications being developed. So when you drive your car, so this will give you an indication of about the nearby charging station. So you need not worry about it. So maybe in future, you may have more number of charging stations. So like what we have our petrol station, so it can go and you can fill it. And this, as far as the fossil fuel powered IC engines are concerned, the fill up time is about 2 to 3 minutes. Whereas the EVs are concerned, you need to wait for at least half an hour to 1 hour to charge about 60% to 80%. So now this range is concerned about 200 to 250 kilometers per charge. They were able to get it, and this is a good for everyday use, especially for local transport. And even when you are planning for long trips, then you can have a break of about 200 kilometers, and where you can charge and you can go in one go. So now the entire concept need to be redesigned, like during the charge. So how the people will spend time. So you need to have a space where you can take rest, and you can have refreshments. So your during that time your car will be charged. So this kind of thing, right? So these are all the cultural changes are required. So now if you have a ICE engine powered vehicles, you can directly go with about 300 350 kilometers, say example from Trichy to Chennai in one go, with a short break of about 10 minutes coffee break time. But this is not possible with the EVs because the range matters. So you need to have a break of about 1 hour or 1.5 hours. So you need a place, right? You need to identify a place where you can take rest, so you can have a charging station. So all those things, right? We have to adapt the customer, and we have to develop the infrastructure facility. Then only it is viable, and people can opt for the EVs. So these are the EVs today available in the market with different range, like Fiat, Honda, Clarity Electric, Nissan Leaf 1, so Nissan Leaf 2. So you can see the corresponding the ranges. So it starts from 50 to 150 miles with the different versions. So the Tesla Model 3 long range, you can have up to or even more than 300 miles. So the next is a plug-in hybrid electric vehicle. So now you have an advantage of the IC engine as well as the electric vehicle. So the first one was electric vehicle, pure electric vehicle, and this is a hybrid electric vehicle. So you have both IC engine as well as the motor and battery systems. So it's a hybrid system. So here the questions whatever we had earlier, like the range or the charging, all those things can be minimized, because when you lose the charge, you can run your vehicle with the IC engine and you can complete your travel. So some of the advantages are there with hybrid systems. So the gas stations or the petroleum refueling stations where you can fuel your tank, and you can take electricity from the household electricity or through from charging stations. So that it solved many of the problems, especially on range, as well as it reduces the anxiety among the people. So these are all the varieties, like plug-in hybrid electric vehicles. So the different ranges for EVs. So you have the combination of both EV as well as the IC powered. So these are the various models available worldwide. So this hybrid relies on gasoline to power IC engine, and drive using electric motor at low speeds and while cruising. And the electric motor increases the fuel efficiency and decrease the emission. And battery automatically recharge while driving. So these are all the regular hybrid. And it's an ecosystem of the EVs where you have a combination of both petroleum stations as well as the electric systems you have a smart grid where you take power from the renewable sources, which is used for powering your lithium-ion batteries. And the vehicle informations, the vehicle's been connected to the internet, and all the information is being accessed by the automotive manufacturers for the major data collection for safety and security, as well as during emergency support. So now the entire system have changed. So always you feel connected with the customer care support from the automotive manufacturer. So this is the start of the EV. Actually, it started by 1830, and from the battery vehicles. From that, we moved stage by stage. And in 1968, the great electric car race were conducted. And in 1970, clean air car race been held at MIT and Caltech and Boston Electric Car Club. They and Toronto University, they worked towards and conducted this race. And earlier it was non-chargeable batteries till 1830s, and then chargeable batteries have come up with 1859. And lithium-ion batteries since early 1990s, and deployment of electric-powered trams came in 1890s. Okay, so these are all the advancement of EVs. So these are the requirements for the charging stations, the AC level 1 and AC level 2 and DC fast charge. So there are some specifications like voltage and amps and charging loads, charging time for the vehicle. When it comes to the AC level 1, you have 3 to 5 miles of range per hour. In AC level 2, you have a charge time for about 10 to 20 miles of range per hour. And DC fast charge, you have 80% charge in 20 to 30 minutes. So now people are more comfortable because of this DC fast charge machines. But normally this is available only in a commercial places, what we call charging stations. In future, you can see this kind of DC fast charging stations in almost in all petroleum stations. So they also come forward to install it, so that in 20 to 30 minutes, you'll be able to charge 80%. So home charging level 1 and the dedicated 120 volt circuit standard outlet. So these are all the requirements for making it the home charging. And this for level 2, dedicated 240 volt, 15 to 50 amp circuit. And this is a public charging. So you have an public charges typically found in parking garages and lots. And there's a universal plug, what J1772. This Tesla provides this adapter. So there's a standard system of level 3, what we call DC fast charging. So it's about 50 to 300 watts. It's a very high power. So this is what the finding the charging stations. Of course, this is slowly booming in India, and most of the countries, they started sharing this information. So this is useful for the customers to identify the places, so they can plan their travel without any anxiety. So there are many benefits. So what we claim is a fewer emissions and cleaner air and better health. So this is what the major objective of moving with EV. And the number of deaths due to the pollution, this is very alarming. So number of deaths due to pollution is much higher in India than other developing or developed countries. And as per studies conducted, deaths due to pollution is 8 times higher in India than neighboring country, even like Pakistan, and more than US. And due to India's large population density, and deaths occur more often than any other country. And there was a survey related to this the pollution. So about 50 million people are dying because of pollution, respiratory illness, mainly from automobiles. So that is one of the major threat for human beings, right? Because CO is highly poisonous, and similarly the NOx are causing the acid rain, and smoke is highly dangerous, as the soot particles are carcinogenic in nature, which causes for the cancer. So this is a major reason why we are moving away from IC engine powered vehicles. And the major factor that attracts the EV are you should go electric due to these major factors. So reliability and flexibility, which the EVs require less maintenance. And the new models hitting the market also offer more flexibility of car size and style. I think now you can see the cars have come with many features recently introduced. So you have all modern systems because you have more space available. So you can have all internet and communication systems and comfort systems, audio, video, visuals, less noise and less vibrations, right? So, and even you'll be able to make it more aerodynamic. So a lot of flexibilities are there with design and affordable. So electric cars are less expensive to fuel and maintain. And of course, once the EVs were introduced in India, it was sold for about 25 lakhs and above. But now it has come to the lower prices. Even you'll be able to get for 8 lakhs, 9 lakhs, 10 lakhs onwards. So it is almost a competitor to the IC engine powered vehicles. So now people are affordable. That's why you will be able to see many EVs on road today. And growing infrastructure, you can plug your car in right at home or the charging stations when you are on the go. And electric cars don't spew the tailpipe pollution that link to asthma, heart attacks, or poor health and premature death. So this is a major concern. So it's a comparison between the electric and IC engine powered vehicles in terms of this price and fuel consumption and ownership, then CO2 reduction. So the challenges for EVs. So basically, the electric vehicle infrastructure is a major challenge, as there are certain guidelines from Ministry of Power, like the vehicles on road to be electric by 2030. About 30% of share will be there, and about 60,000 crore units increase in power demand, and more power need to be generated. This is electricity demand by EVs in 2030. So for car, taxi, buses, and two-wheelers and three-wheeler sector, okay, the electricity demand. So according to the NITI Aayog Energy Policy Study, India's energy consumption would double by 2040 with the electricity consumption, potentially tripling as a result of increasing appliance ownership. So given that 80% of country's population uses electric vehicles, India is expected to require more electricity, about 5% of total electricity by 2030. And these are the challenges like limited range, long range times, high initial cost, battery life, and consumer acceptance, and grid integration. So this is a comparison of this gas, what we call as a petrol, with the batteries. So you have more weight addition. It's about 2.7 kg of your fuel, like petroleum fuel, where when you go for same energy, then you need to have 340 kilograms. So here the weight is being added more. So this is the major concern when we go towards EVs. So now we have to work on alternate battery technologies where this weight can be minimized. So the in order to avoid this range anxiety, so this is one of the method being proposed, like battery swapping versus the fast charging. So fast charging, you have to wait for about 30 minutes. Whereas if you are going for battery swapping, so this kind of batteries already charged, batteries are available in the battery swapping center. Just go and park your vehicle, just you replace the battery with the charged one and you can go. So this is similar to how you refuel it in your fueling stations with your conventional fossil fuels. So this is one of the technique proposed. And there are some of the EVs available today. So when it comes to the design, especially the aerodynamics is concerned, so you have a more space to have a aerodynamic design, because you are going to keep all the batteries at the bottom, and only the motor and transmission systems are there, which occupies very less space. So you can have more space for keeping your luggage, as well as in order to have a aerodynamic shape, there is no hindrance. So this is a Tesla Motors vehicle, about top speed about 125 miles per hour, and acceleration 0 to 60 in 3.7 seconds. Range become 244 miles. And the many models are going to come. So when it comes to the government part, because these are all the factors related to the EV, introduction of EV, and the purpose why the EV is very important, and what government has taken initiative, and what are the policies have been developed. So it actually started by 2010. The Indian government announced a strategy to reward OEMs with a budget of about 950 billion rupee. And 2012, the incentive program was scrapped, resulting in a 70% reduction in electric vehicle sales. In 2013, the government has established the National Electric Mobility Mission Plan 2020. And then 2015, there's another scheme called FAME, one launched by 1st April 15 till 31st March 19 by the Department of Heavy Industries. They allocated a total financial of about 5.29 billion rupee. And then by 2019, they introduced the FAME 2 program, commenced from 1st April 19. The Union Cabinet approved an outlay of about 100 billion rupee, and the taxes reduced to 5% on EVs and electric chargers. And recent state policies, so different states have shown interest to introduce the EV. So it's again a government, they have given the incentives for encouraging the customers. So the Delhi electric vehicle policy, it started by 2020, and by 2024 the goal is for about 25% of new car registrations to be electric. Okay, so this is now in place. So more we can see on road, right? So more number of EVs are spotted in the recent years by 2024. Yeah, monetary buying incentive of rupees 5,000 per kilowatt hour of battery capacity provided for two-wheeler and based on a maximum reward of rupees 30,000 per vehicle. And the incentive of scrapping off, deregistering old highly polluting two-wheelers. Purchase incentive of 30,000 per vehicle to owners of e-rickshaws and e-carts and e-autos. So when it comes to the user, right? So the user have 1,000 questions to go with EVs because they all practiced and by habitual, it is very difficult to change their mindset moving away from the traditional IC engine powered vehicle. So the basic logic from the government is to give some subsidy for purchase of new vehicle, and there are some tax benefits being offered. So this is a starting point where they were able to satisfy some kind of customers, because once the customer is more cost focused, then they see these options available and they are ready to buy EVs. And Maharashtra electric infrastructure vehicle policy, it was implemented by 2018, and target to increase the number of EVs in Maharashtra to 5 lakh throughout the course of 5-year policy period, and enabling fuel station to set up charging station. So this is what more convenient because you can see more fuel stations are there. So there are also space for setting up the charging station. So this is what the Indian Oil Corporation, they have come forward to set up the charging stations. And UP electric vehicle manufacturing and mobility policy, it was implemented in 2019. So rolling out 1 million EVs combined across all segments by 2024. And goal of 1,000 electric buses deployed in state by 2030, and a target of achieving 70% electrification of public transportation by 2030 on identified green routes in 10 identified EV cities, and set up around 0.2 million slow and fast charging and swapping stations by 2024. Right. So you can see in all the policies, okay, so they have a 5-year plan, and it's all end by 2024 just now. Now just we landed up with 2025. Okay, so you can expect right the next level of policy, which is more inclined towards the EVs. When it comes to the Tamil Nadu electric vehicle policy 2019, So they encourage investment in electric mobility and make Tamil Nadu a manufacturing hub for EV and ancillary equipment. And they are having the aim of about 1 lakh EVs on road by 2022, which include 80,000 two-wheelers or scooters and 14,000 three-wheelers and 4,500 cars and 1,500 buses. So to somewhere even it exceeded today. And in some places where it does not happen, like say example, the buses are concerned, we have say a very slow movement on EV buses. Whereas the two-wheeler and four-wheeler sectors are concerned, we have on par with what the government planned. Here the incentive from 100% from registration fees and 50% exception from motor vehicle tax. When you buy a ICE engine powered vehicle, you have to pay a huge amount for your registration. Say example, less than 10 lakh worth vehicle if you are buying. So it will be around about 1 lakh you need to pay as a registration fee. Whereas if it is your cost of your vehicle is more than 10 lakh, then your slab will change, and accordingly you'll be paying about 2 lakh and above. So this is what, right? The registration fee is more for traditional ICE engine powered vehicles. So when it comes to the EV, so you have 100% registration fee, so you have the savings of about 2 lakh here, and 100% exception from electricity duty for e-charging stations. So these are all the benefits announced by Tamil Nadu government. And similarly, the Gujarat and the Karnataka electricity boards, they developed the policy. So this is about the electric vehicle unit sales in India, because these kind of policy have been introduced by the government. So you can see a steep or gradual rise of the EVs on road, especially on two-wheelers and four-wheelers. So now you have a statistics from 2015 to 2020. And similarly, the EVs component industry growth for motors, batteries, and power electronics and charging stations. So these are statistics, electric cars as proportion of the number of cars in the country in percent. So now we have the list among the Norway, Iceland, Netherlands, and Sweden, China. And these are the most popular brands, electric cars. So this is a timeline for various initiatives taken by policymakers and regulators. So from 2011 to 2020. And this is an incentive offered. Total approximate incentives for two-wheelers, it's about 15,000 rupees per kilowatt hour up to 40% of the cost of vehicle. And approximate size of battery is 2 kilowatt hour. And for three-wheelers, about 10,000 per kilowatt hour, and four-wheeler again same. And e-buses about 20,000 per kilowatt hour, and e-trucks similarly the same. And this is the Department of Heavy Industries. They also sanctioned about 2,636 charging stations in 62 cities across 24 states and UTs under the FAME India scheme, phase 2. And state-wise allocation of this charging stations you can see. So the government policy and new initiatives. So this is the National Auto Policy, NAP 2018 is a draft. And government unveiled draft NAP in February 2018 with a vision to promote green mobility in the country. And they have the objectives with increased contribution to GDP to support the growth of industry and comprise a considerable proportion of the manufacturing sector GDP by 2026. And increase exports to scale up exports to 30 to 40% of the overall output over the next decade. And improve the brand recognition, competitiveness, and technological advancement of the Indian automotive industry across the world, and drive employment generation and skill development to become a solid foundation for job creation over the next decade, and increase local R&D investments to drive the R&D efforts towards indigenous research, design, and engineering, and to promote clean, safe, efficient, and comfortable mobility with a focus on environmental protection and affordability. So these are all the objectives of this National Auto Policy 2018. This is the Automotive Mission Plan, AMP, 2016 to 26. So it's a collective vision of Department of Heavy Industry and Indian automotive industry. And they have set the objective to propel industry to become the engine of the Make in India program. To make industry a significant contributor to the Skill India program. I think you can see this Make in India and Skill India is more popular. Promote safe, efficient, and comfortable mobility for every person in the country with an eye on environmental protection and affordability through both public and personal transport options. To seek increase of net exports of the Indian automotive industry several fold. Promote comprehensive and stable policy dispensation for all regulations impacting the industry. And this AMP, Automotive Mission Plan 2026 is aimed at bringing automotive industry among the top 3 of the world's in engineering, manufacture, and exports of vehicle and components, growing in value to over 12% of India's GDP and generating an additional 65 million jobs. And this is the National Electric Mobility Mission Plan, NEMMP 2020. And this was introduced jointly by government, automotive industry, and academia and research institutes. In promotion and development of indigenous manufacturing capabilities, required infrastructure, consumer awareness, and technology. And 6 million electric and hybrid vehicles per year on the road by 2020. Then faster adoption and manufacturing of hybrid and electric vehicles. That's a FAME. It was implemented in 2 levels, FAME 1 and FAME 2. Initially, FAME 1 as part of NEMMP was launched in 2015 for 2 years, and but was extended from time to time till March 31st, 2019. And FAME 2 with an outlay of about 10,000 crore has come into effect on April 1, 2019 for 3 years. And about 1,000 crore has been earmarked for establishment of charging infrastructure as per charging infrastructure for electric vehicles guideline and standards released by Ministry of Power. And over 20,000 EVs have been supported till September 2020 by way of demand incentive amounting to about 95 crore. And this is another policy, National Automotive Testing and R&D Infrastructure Project, NATRIP. This is most significant initiative in automotive sector by Government of India, with a total project cost of rupees 3,727.3 crores, and creating core global competence in automotive technology in India, and to facilitate seamless integration of Indian automotive industry with the world. And 4 new centers are International Center for Automotive Technology, what we call as a ICAT, at Manesar in Haryana in northern India, and a Global Automotive Research Center, GARC, at Oragadam near Chennai in Tamil Nadu in southern India, and National Automotive Test Track, NATRAX, at Pithampur near Indore in Madhya Pradesh in central India, and National Institute of Automotive Inspection, Maintenance and Training, NIAMNT, at Silchar, Assam, in Northeast India. So these 4 centers have been developed for testing this automotive systems, so that we have a R&D on par with the global market. And these are the EV policy initiative by Indian states. So, so different states have different policies, like Andhra Pradesh, Karnataka, Kerala, New Delhi, Maharashtra, Madhya Pradesh, Tamil Nadu, UP, Telangana, Uttarakhand, Bihar, Gujarat, Punjab, Haryana, Chandigarh, and Meghalaya. So, right. So different states have come up with different policies for implementation of EV and adoption of EV. And there are some other initiatives. Government of India encourages foreign investment in the automobile sector and allows 100% FDI under the automatic route. And government has reduced goods and service tax GST on EV to 5% from 12% on charges and charging stations for EVs, from 18 to 5%, and allowing sale and registration of EVs without batteries. So these are all the incentive given by the government to promote the sale of the EVs. Then Ministry of Power has allowed a sale of electricity as a service for charging of EVs. Ministry of Road Transport and Highways is allowing the grant of license to age group of about 16 to 18 years to drive gearless e-scooters and bikes up to 4 kilowatts. So this is again another new addition, because for as per Motor Vehicle Act, one should have about 18 years of age to get the license. But here they have come up with the license for e-scooters. It's a gearless drive. Ministry of Housing and Urban Affairs has made amendments to the Model Building Bylaws 2016 and Urban Regional Development Plans Formulation and Implementation Guidelines 2014, making provision for establishing EV charging stations in private and commercial buildings. So this gives a lot of opportunity for the customers to buy EVs without worrying about the charging stations. Then phased manufacturing program for electric mobility. Access roadmap for industry to make necessary investment to localize EV and component production, and enable the country to manufacture batteries at large scale with an initial focus on the battery pack assembly plants, and followed by integrated cell manufacturing. And this is valid for 5 years till 2014. So just now it got over. Then production linked incentive PLI scheme. The government announced an outlay of about 75,000 crores for automobiles and components, including batteries, under PLI scheme. And detailed schema to offer PLI will come out soon, and will lay roadmap and raise India's bar as a global manufacturing hub. And vehicle scrapping policy, this also they have proposed. Recently, the Union Road and Transport Minister announced the vehicle scrapping policy in the Lok Sabha. They aim to reduce the population of old and defective vehicles, bringing down vehicular air pollutions, improving road and vehicular safety. So you can see already we have certain guidelines in force, like you can operate up to 15 years. After that, you can go for extension about another 5 years. So now government have come with certain incentives for scrapping your old vehicle, so that, right, the old vehicles are giving more pollution than the new vehicle. So it is again another initiative to reduce the environmental pollution. as well as the vehicle accidents are concerned because of the defective components or systems or failure of the components and systems. More accidents have cropped up. So now government have given a scrap value of about 4 to 6% of ex-showroom price of new vehicle to be given to the owner by scrapping center. State may be advised to offer a road tax rebate of about 25% for PV and up to 15% for CV. So the registration fee may also be waived for purchasing the new vehicle. So these are all the initiatives and incentives have announced by the government on vehicle scrapping policy. And there are technical regulation and standardization, because when you are moving towards the electric vehicles, the regulations have given by the organizations like Ministry of Road Transport and Highways. They formulated and implemented various provisions of Motor Vehicles Act, MVA, and the Central Motor Vehicles Regulation, CMVR. And MORTH has 3 committees to deliberate and advise the ministry on issues relating to safety and emission regulations, namely the CMVR, that's a technical standing committee, and another standing committee on implementation of emission legislation, and automotive industry standards committee, AASC. These standards are formulated by VAS and RI and are considered CMVR TSC for implementation. These vehicles manufacturers have to comply with relevant Indian standards, that's IS standards, and automotive industry standards, AIS standards. Then India signed an UNWP 29/1998 agreement in February 2006. And India has currently more than 70% safety regulations, which are either partially or fully technically aligned with the GTR and UN regulations. And the BAA standards, and they have 2 division council and the Transport Engineering Division Council, TEDC. They covers standardization in the field of transport engineering, including air, water, road, and rail transport. And 19 technical committees and published more than 1,160 standards. And TED 27 addresses electric and hybrid vehicles, and mirror committee of ISO TC 22, SC 37, and IEC TC 69. TED 29 addresses intelligent transport systems, and the mirror committee of ISO TC 204. And TED 30 addresses the railway applications. And another council is Electrotechnical Division Council, ETDC. So they are responsible for standardization in the field of electric power generation, transmission, distribution, utilization equipment, and insulating materials, winding wires, measuring and process control instruments, and primary and secondary batteries. And this is Automotive Research Association of India, ARA. So they have different guidelines. So they focus, this is a government approved test agency to carry out mandatory certification testing. So the automotive manufacturers are approaching Automotive Research Association of India, situated in Pune, ARA Pune. So they take their vehicle to RI, and they are empowered to test and provide the test certificates for operation on road. So they provide technical expertise in R&D, test certification, and homologation, and framing of vehicle regulations. So they are having different standards like GRPE, they working party on pollution and energy, and GRSG, they are working party on general safety provisions, and GRRF, working party on brakes and running gear, and GRE, working party on lighting and light signaling, and GRB, they are working party on noise, and the GRSP, they are working party on passive safety, and they published different standards that are related to electric and smart mobility. And the Ministry of Heavy Industries and Department of Heavy Industry, so they instituted the Committee on the Standardization of Protocol for Electric Vehicles to develop specifications for public charges for such vehicles. The committee submitted the report to the Government of India by 2017 and has come out with the recommendations entailing specification for AC and DC charging for EVs. These standards are called Bharat EV Charger AC001 and Bharat EV Charger DC001. These specifications are intended to cater the immediate need for existing and announced electric two-wheeler and electric three-wheeler and passenger cars vehicles having battery voltage less than 100 volt. And Government of India has also considered the recommendations made by the committee and has adopted the report on Bharat Public EV Charger specifications submitted by the committee. And there are international cooperation on auto sector. You have India, Germany, India, Netherlands. So with this, I'll conclude my session. So no single technology development or alternative fuel can solve the problem of growing transportation fuel use and greenhouse gas emissions, which was said by the famous professor and scientist John B. Haywood. So thank you for your attention, and any questions are welcome now. Dr. S.V. Saravanan.
Professor, tell me, Professor.
Yeah. So any questions? I'm happy to answer.
Good evening.
Aravind has told, thank you, sir. Thirumurugan has told, thank you, sir. Very nice presentation from Aravind. Dr. K. Sendil Kumar, thank you, sir. They are congratulating you, Professor. There is no questions from participant side.
Okay.
Since expert lecture you are given by both the sessions, you can leave them for 5 to 10 minutes, sir. By if any recorded video is there, you can play it so that we can start the next session, sir, session 4.
Yeah. Okay, Professor, I'll leave now and I'll join by 7:30.
Yeah. Is there any video, sir, related to this? You can play it.
No, Professor, not needed for this session.
Okay, sir. Okay. So, Professor, please take rest and please join us by 7:30.
Yeah. Thank you. Thank you, Professor.
Participants, you also please take a short break of 5 to 10 minutes. We will join by 7:30. Professor Dr. Arul sir. Professor Dr. Arul sir.
Hello.
Sir, வர்றீங்களா ஆன்லைன்ல? sir. Dear participants, wait for some more minutes. The speaker will come in the online. Once he resumes to the online, we will clarify your queries of the session 3.
Hello.
Professor,
Professor, good evening.
good evening, Professor. Before proceeding to the session 4,
Yeah.
there are some clarifications from the participants.
Okay.
Dr. M. Karthikeyan has raised a query that disposal of battery affects the environment. How to prevent it?
Yeah. So at present, there is no regulations available for disposal of batteries, because now to certain extents we are going for recycling of batteries. Especially now we are working on whatever automobiles are having is the lead acid batteries, so it is recyclable. Just we change the electrolyte and we make it into action. So that's what partially it is being done. So when it comes to the lithium-ion batteries, so disposable of such batteries, so far there is no regulations present, but you can't simply throw it in an open place. So there will be regulation. You need to store somewhere, and then it has to be kept. So the environmental impacts and analysis will be done in future. But at present, even the automotive manufacturers, they have come up with programs such as you need not to own the battery, so you are going to get lease the batteries for about 5 years. So you are paying money only for purchase of your car, not for the battery. So the price of car also have come down. So you'll be able to get a car for about 5 lakh to 10 lakhs by buying only the car. The battery is a property of the automotive manufacturers. So once the battery life goes away in 5 years, they replace it with a new one, and they buy back or get back their old batteries. And so this is what, right? So now they have started implementing with the new proposals. Maybe in future, this will be a very big problem about environmental pollution because it's again, right, a solid. So there is a research which focuses on IC engine powered vehicles. So now we have a very lean emission standards like Euro 6 norms or Bharat 6 norms, where all the emissions are very lean. So what is available in a normal atmospheric air, so that is highly polluted when you compare the tailpipe emissions, because in tailpipe we have a catalytic converter and the particulate filters. So all those things are capable of filtering out the harmful emissions, so that the tailpipe emissions are cleaner comparing to the emissions what is available in the atmosphere. So this is what the research says. So the inlet air is highly polluted, what is being taken into the IC engine, and then when it comes to after burning, it gives power out, and then the tailpipe emissions are cleaner. So there was a proposal, you run more and more lean emission engines, so that your air is being cleaned off, like how it is being filtered off. So when it comes to the battery vehicles, so this is going to be a very big challenge in future, and that is under progress.
Thank you, Professor, for your great explanation. Next, another participant, Padma Saini Rajendranath, has asked, "Sir, could the conventional vehicle converted into electric vehicle? Is there any government policy?"
Actually, the scrapping policy have come up because again, what you're asking for retrofitting. So this retrofitting, definitely the automotive industry will not come up. But there are some organization, unauthorized organization, they are doing this kind of job. So this is more cost effective, especially when you are giving your two-wheeler, IC engine power two-wheeler, in 30 minutes or 1 hour. So they are able to convert your IC engine powered vehicle into electric two-wheeler. So this kind of things are not being approved by government, but some local authorities, local mechanics are doing this kind of modification. But this is not in actual government policy. So they are actually planning for scrapping of the old vehicle, and they are encouraging to buy the new vehicle so that the pollutions are coming down. So this is the major objective of the government.
Yes, Professor. Thank you. Another again, Dr. M. Karthikeyan asked, in our country, people connect it in home connection for EV vehicles. Is it advisable, sir?
Yeah, actually, when it comes to the charging, so you have two options. One is home charging, another is a charging station that's operated on DC power. So I have shown in the power plant.
In PPT also you
PPT.
explained very nicely.
Yeah, so there is a level of charging, level 1, 2, and level 3. So level 1 and 2, you have charges at home. It's a home charging. So it is safe for home charging, but there are some accidents happen recently reported, especially while charging the two-wheelers. Okay, so there are some technical modification which is done by local mechanic or somewhere. So they modify the electronics part of the two-wheeler. So that could be one of the reason where there is an explosion, right? The battery explosion. The charging and discharging cycles being concerned, it is carefully designed. So there is a circuit to prevent the overcharging. So when it comes to the batteries, you have more number of smaller cells. So each cell need to be charged and discharged in a uniform manner. When it is not happened, certain cells being overcharged, certain cell being undercharged. So the battery management system, what we call is a BMS system. So when it failed to prevent the temperature measurement of each and every cells, then that causes for the already charged cell will get overcharged, which causes for rise in temperature. So beyond 60 to 70 degree Celsius will lead to explosion of the single cell. So once one cell got exploded, then the heat generated is enormous, which causes for or which is capable of burning the nearby cells. So that's what once the explosion started with one cell, it propagates to the adjacent cells, and all the cells being exploded within right a few minutes. So there is no problem of home charging, but the problem is with the failure of the electronics part in the BMS unit, or there may be a local mechanic modification which is happening generally, right? So this kind of modification alone is a threat for the home charging. Otherwise, there won't be any problem because
without proper RTO approval, correct, Professor?
Yeah. Actually, there are standard plugs available for even for home charging. So required the amps, right? 15 amps plug need to be used for charging. But the people use, right? They take the 5 watts, 5 amps or 6 amps charging. They put the adapter, right? 15 amps adapter, they plug it. So this kind of modification without understanding the knowledge of about electricity, because during charging, so all the cable, right, the wires will get overheated. The cells are being overheated during the charging process. So this need to be taken into account. So whatever the government prescribes, the same plug points and sockets and plug need to be used, especially for home charging. But so it is highly safe to go with charging station because they use a fast charging DC charging machine. So it is highly safe comparing to your home charging, because there is no, because it has been properly calibrated and tested periodically. So there won't be any problem of this explosion happens. Otherwise, there is no issue.
Okay. Thank you, Professor. Another participant has asked the ATAL AICT ID number, that I will put it in the common group. Swati Gupta, I will put it in the participants group of ATAL ID. Don't worry, the application number and ATAL ID. And majority of the participants, Professor, they told thank you, sir. Your presentation was highly informative and insightful, told by Mr. Santosh Kumar A. And another Saroj has told very useful description of the regularity content for EV vehicles. And nice presentation. Thank you, sir. Nice sessions. Thank you very much. Like that, majority of the participants told. And
Yes.
also, so thank you very much, Professor, because we have received very good feedback regarding the session 3. And also, majority of the participants have asked the PPT. It will be shared. Don't worry.
Yeah. I'll share the PPTs. Don't worry.
Yes, yes. Professor, shall we move on to the session 4?
Yeah. We can move, sir.
Yeah. Thank you, sir.
You have any intro part or directly I can go?
Again, once again, we welcome Professor Dr. Arul Selvan sir for the session 4 to give the insightful informations about the recent advancement in battery, because battery is a heart for the EV vehicles, because for IC engines we will tell engine is the heart of the vehicle. Like that, for for e-vehicles, battery is the heart. So this topic is a very neat and vibrant topic. Once again, I request Professor Dr. Arul Selvan sir to proceed further in the session 4 of the topic recent advancement in battery. We welcome you, Professor, once again.
Yeah. Thank you very much, Professor. Of course, keeping in mind of the overall the time allotted, and I have covered some of the fundamentals in the first session. And coming to the second session, I'll share my screen.
Yes, sir. Yes, sir.
Professor, hope you are able to see my screen.
Yes, Professor. Yes, please continue, Professor.
Yeah. Welcome back, everyone. So, in continuation to the government policies, where governments are encouraging to go with electric vehicles. Now, as Dr. S.V. Saravanan pointed out, now the most important part is lying on the batteries. That's a power plant. So, batteries, you have a electrochemical mechanism. So you'll be able to produce electricity through chemical reactions. And now, as I said, there's a challenge for EV because the energy density, what you require is more in order to drive your EVs. So more the energy density and the more the power production, which causes more heat to involve in it, which causes for more heat generation, and there's a need for proper cooling in order to maintain the battery safely. During the development of the electric vehicles, the batteries played a crucial role, and safety of batteries were the major concern worldwide, even the top brands. So the reason was earlier, there was no proper knowledge on the increase of temperature on each and every cells of a battery compartment or battery pack. And there was a battery management system where it monitors each and every cell, and each and every cells need to be controlled by means of a electronic circuit. So the cell which is being highly charged need to be cut off, and then the cells which are all lowerly charged need to be further permitted to charge. So what we call as a cell balancing. So in a period of time, all the cells need to be maintained with the same charge. And similarly, during discharge time, certain cells may have higher or more discharge compared to other cells. So this kind of non-uniform charging and discharging causes for various temperature inside the battery pack, which causes for the higher temperature involvement causes for explosion, because there is a limit, safe limit. So all the batteries need to be maintained about 25 to 35 degrees Celsius only. So we need a proper cooling system in order to cool the batteries. Otherwise, this causes for explosion. So when it reaches above 650 or 60 or 70 degrees, then at any point of time, this may catch fire. So it's a major concern over the batteries. The key role in the sustainability. So batteries are essential for enabling the transition to renewable energy sources, facilitating energy storage that stabilizes the grid, reduces fossil fuel reliance, and support sustainable practices in various sectors, including transportation and healthcare. So when it comes to the batteries, and our focus is only towards the transportation sector. So now we are in a move of working towards the sustainable and green energy. So we are depending on the renewable energy sources, and these renewable energies like solar or wind, the energy produced will be used for producing electricity, and this electricity being stored in batteries. So when the batteries are being powered, so this power can be used for running the electric vehicle. So this is what, right, we are planning for the sustainable energy sources. So you have a role in renewable integration. So energy storage systems facilitate the integration of renewable sources by balancing supply and demand, ensuring a stable energy flow despite intermittent generation. So if you take the renewable energy, so the major problem with renewable energies are time dependent when you consider the solar energy. So the solar energy production is optimum from 9 a.m. to 5 p.m. So then during night times, you won't produce. So during daytime, whatever you produce, the electrical energy will be stored in the batteries. And when it comes to the wind energy, so this is 24/7, but not 365 days. So some period, right? So you get more wind, some you get less wind. But of course, we need to identify the place where we get a minimum wind velocity in order to operate the windmill. So what we call as a wind parks. It's again location specific. So in India, we have identified some of the locations where wind energy is being harnessed through wind parks. So we generate electricity through windmills, and which is being given to the grids. So now in the recent years, you could have experienced there is no power cut in Tamil Nadu. because the peak demand is being substituted by means of power generation through the major share from the windmill. And so now we are able to supply based on the demand. So fortunately, we have power for 24/7 and for 365 days. So this is what, right? When you integrate renewable energy, then we'll be able to have a sustainable energy for the future. Then the economic benefits, you have enabling time shifting of energy usage. Then ESS allows the consumers to capitalize on lower energy cost, enhancing overall economic efficiency in energy consumption. And the environmental impact is the adoption of energy storage technology significantly reduces the greenhouse gas emissions, promoting a cleaner energy landscape and supporting global sustainability goals. So this is the major requirement for moving towards this renewable energy integration. So it gives a lot of opportunities for reducing the harmful gases and mainly the greenhouse emissions are being reduced. I think recently we are experiencing a significant change in climate, what we call climatic change because of the greenhouse gas emissions. So here we have certain objectives. The technological innovations is related to the examination of the cutting edge battery technologies, highlighting their unique features and potential to transform energy storage solutions across various application and industries. And the second objective is to sustainability and environmental focus to analyze the environmental implications of battery production and disposal, emphasizing the importance of sustainable practices in developing future battery technologies to minimize ecological impact. The basic components, you have an electrochemical cell and the separator. The electrochemical cell is crucial for energy conversion with reactions at the anode and cathode, determine the efficiency and performance during the charge and discharge cycles. The separator is used to prevent the short circuit by allowing ion flow while maintaining the physical separation, enhancing battery stability and lifespan through advanced material innovations. When it comes to the efficiency, the current collectors minimize the electrical resistance, significantly impacting the overall battery performance by ensuring effective electron flow between electrodes during the operation. This is a charge cycle dynamics. So this involves a systematic process where energy is stored through electrochemical reactions with a distinct phase, ensuring efficiency and safety during the charging process. The discharging mechanisms, during the discharge, electrochemical reactions convert stored chemical energy back into electrical energy with the lithium ions, facilitating electron flow, crucial for powering the devices. The charge and discharge efficiency is influenced by internal resistance, temperature, and state of charge, all of which significantly impact battery performance and longevity in practical applications. So we had an experience of using the mobile phones to, nowadays. You can see the charging time and discharging time. So the newly purchased mobile phones, once you charge, when it has been charged 100% or 90%, then at least it lasts for 1 day, at least till the evening, and you can charge during night times. But as you move on by a number of days and months, you can see the efficiency drops out. Even the charge won't stand till 9 p.m. or 10 p.m. So when you move towards a year, then the charge will go by 5 p.m. or 6 p.m. So what it reflects is the charging and discharging, you have a logic. and this need to be controlled effectively in order to improve the efficiency of your batteries. There is a guideline on batteries, so the battery should not be charged to 100%. So this everyone should understand. So battery should be charged to about 80 or maximum of only 90%, not more than that. And similarly, when you want to discharge, during the discharge cycle, you can come down up to 20%, and the worst case, you can come up to 10%, not below this. And you can see most of the people forget to charge or discharge by following these guidelines. So they charge for 100% or they discharge 100%. So this causes for major change in the temperature and affects the resistance, which causes for the reduction of this life. So it is advisable to go for charging, discharging within this percentage of 10 to 90%. So which increases the efficiency and life of your batteries, which is applicable for your EVs. So charging and discharging and the state of charge, right? So even as you start working on battery, like charging and discharging, as the number of cycles increases, the battery capacity will not be showing to 100%. It starts decreasing to 90% and 80%. So in such case, the battery itself comes to about 80% or 70%. That means you will not be able to charge beyond the 70%. So in such case, right, so the efficiency drops out, then it is recommended to go for purchase of a new one. So normally this happens in the time frame of about 1 year, 2 year, 3 year, 5 year kind of thing. Okay. So the automotive manufacturers, they give a number of cycles based on the regular operations. So they give the lifetime for battery pack for about 5 years to 9 years time. You have a classification of the batteries into primary and secondary types, essential for selecting appropriate energy storage solutions, optimizing performance and addressing environmental concerns associated with the battery usage and disposal. In the usage context, the primary batteries are ideal for low drain devices, while secondary batteries excel in high drain applications requiring frequent recharging, such as smartphones and electric vehicles. Life cycle and stability. The secondary batteries promote sustainability through reusability, whereas primary batteries contribute to waste due to their single-use nature, impacting the environmental health. So this is the question raised by some of the participants in the first session. The life cycle of this battery. So the primary batteries are mainly for single-time use, and secondary batteries are meant for reusability. The technological advancement, so innovations in battery technology, including the solid state, lithium sulfur batteries, and enhances the battery performance metrics, addressing efficiency and sustainability challenges in both primary and secondary categories. The rechargeable batteries are integral to various sectors, powering everything from consumer electronics to renewable energy systems, thereby supporting technological advancement and sustainable practical globally. Then the performance enhancements, the ongoing research focus on improving the energy density, the cycle life, and safety features in rechargeable batteries, ensuring that they meet the growing demands of modern applications and environmental standards. The development of efficient recycling methods and use of eco-friendly materials are crucial for minimizing the environmental impact of rechargeable batteries, promoting a circular economy in battery production. Then energy density versus the safety trade-offs. The balancing performance and safety is very important. The pursuit of higher energy density in batteries necessitates advanced safety mechanisms. That's increased energy storage can lead to overheating and potential hazards during operation. So you can see the some of the incidents that happen during charging as well as discharging the two-wheeler caught fire, and even some four-wheeler caught fire during discharging cycles. So now, when we are talking about the higher energy density, because we are focusing towards higher range, right? So the EVs are expected to operate for high range, about 200, 250 or 300 kilometers range per charge. In such case, right, when we focus on higher density, which causes for more heat generation. So this heat need to be released through effective cooling systems, then only it is safer for operation. Otherwise, the overheating causes for explosions. Then innovative material is one of the alternate solutions. The emerging battery technologies such as solid state batteries utilize safer materials that enhance energy density while mitigating risk associated with the traditional liquid electrolyte systems, promoting overall reliability. So now people started working on solid state batteries where it is safer for operations. The environmental impacts of battery. So based on the production, so ecological disturbance from the mining. So this is a major concern. So in the previous session, we have discussed about the IC engines are giving less pollutions comparing to the EVs in certain cases. Because, right, you take the hydrocarbon fuels, you burn off and use a catalytic converter and particulate traps, so that you convert harmful emissions into harmless emissions in catalytic converter. So CO is being converted into CO2, and nitrogen oxides are being reduced to nitrogen and oxygen, and soot particles being trapped in a particulate trap, and then it is burned off with the regeneration technique, like by supplying the additional fuel in the frequent interval, we are burning off the soot particles. So the tailpipe emissions are almost clean comparing to the inlet air. So this is what the trend with the IC engines. When it comes to the EVs, then EVs, the batteries are the culprit, because we use the raw materials. So this being extracted through mining operation. So the mining operation requires a lot of energy for extraction of these materials, especially the lithium is concerned. The extraction of lithium and cobalt often leads to inhabitat destruction and water scarcity, significantly impacting the local ecosystems and the communities. Then the greenhouse gas emissions, the battery manufacturing process are energy intensive, and primarily relying on fossil fuels, because for mining operation, we have to operate many machineries which contribute to increased greenhouse gas emissions and causes for this climatic change. The challenges in recycling, inefficient recycling practices results in hazardous waste, with many batteries end up in landfills, posing risk of soil and groundwater contamination. So these are the major challenges related to the batteries. So once this has been addressed, then you can claim this is a clean source of covering the transport. And cost and scalability challenges, so the market volatility impact, the fluctuations in raw material prices are driven by geopolitical factors and supply chain issues significantly affect battery production cost, necessitating strategic planning and risk management to ensure sustainable scalability and in the manufacturing processes. Environmental impact mitigation. So effective battery recycling reduces hazardous waste, preventing toxic material from contaminating soil and water, thus protecting ecosystems and public health. Economic incentives for recycling. So developing cost-effective recycling techniques can enhance material recovery rates, making recycling financially viable and reducing reliance on virgin resources. So in foreign countries, right, so they offer incentives when you give it back your used batteries and the e-waste, so that right, the environmental pollution being minimized through the recycling techniques. And even some of the countries, you are not permitted to throw the batteries or e-waste in a open space in an atmosphere, which is offense. So we have to follow only the regulations laid by country from time to time. And regulatory framework development, the establishing consistent regulations across jurisdictions can streamline recycling processes, promote responsible disposal, and encourage consumer participation in battery recycling initiatives. And enhancing energy efficiency, this is the importance of the advancement. So innovations in battery technology led to improved energy efficiency, reducing waste and optimizing power usage across various applications from consumer electronics to industrial systems, and supporting renewable integration and promoting the economic growth. So there are advancements on the lithium-ion battery, because lithium-ion is considered one of the most viable and reliable source for powering this EV. You have a high capacity anodes, example, the silicon based. This high capacity anodes, such as silicon based materials, are revolutionizing the lithium-ion battery technology by significantly enhancing the energy density. So these are with a theoretical capacity of about 4,200 milliamp hours per gram, was nearly 10 times the capacity of conventional graphite anodes. However, the challenges, just volumetric expansion during cycling and mechanical degradation and reduce the electrode stability, hinder their practical use. So these are all the limitations. And recent advancement in nanostructured silicon and silicon carbon composites and binder innovations aim to address these issues, paving way for longer lasting and high performance batteries critical for electric vehicles and renewable energy storage systems. So we have a different techniques for enhancement of the performance of this battery. Like we work on the mechanism, basically the material science aspect, like the silicon based anode, and nanostructured design, like porous, hollow nanotubes and thin films, etc. And the carbon coating and metal dropping and other composites where hybridization being employed. And this causes for the future directions for emerging technologies, which is cost control. And another research on the new electrolyte technologies for safety. So there are innovative safety mechanisms like emerging electrolyte technologies such as solid state and hybrid systems significantly enhance battery safety by reducing flammability risk and improving thermal stability, thereby addressing critical safety concerns in modern battery applications. So as I said earlier, the major challenge with battery is only the safety issue related to the explosion of this battery. So this has been taken care by moving with the solid state and hybrid systems. This creates more safety, so which is more reliable for EV operations. So this fast charging technology is the new and which significantly reduces the charging times for EVs, alleviating the range anxiety and making EVs more appealing to consumers by aligning charging durations with traditional refueling methods. And innovation battery materials such as silicon doped anodes and solid state electrolytes enhances both the charging speed and cycle life, contributing to improved battery performance and safety. So again, when it comes to the material, right? So a lot of research work is going with material science aspects, like how this charging and discharging mechanism takes place, and how about the number of cycles. How about the temperature variations and how to cool down. So all those things requires the knowledge on the material science, like nano structure, nano cooling, nano technology is playing a vital role on this advancement. And sustainability and life cycle management. So the ultimate aim is to go for extended life cycle through optimized charging strategies and new battery chemistries. Not only enhances user satisfaction, but also reduces environmental impact by minimizing battery waste and disposal challenges. So the what we are going is extended life cycles, because every battery is being estimated based on the life cycle. So charging and discharging life cycle. So when you have a uniform charging and uniform discharging cycle, the life of batteries are more. Even you could have experienced the lead acid batteries, which is used in oxygen powered vehicle for starting your engine. So the life, generally they give a warranty for 3 years or 4 years. So if you are not properly maintaining the batteries, the life will come down for about 2 years. So this is based on, right, the charging and discharging cycle, how we operate. So through optimized charging strategies. So this is what, right, the charging strategies. Now we have a battery management system, BMS. So through that, the optimized charging happens. So the aim is to have a uniform charging for all the cells. So there is no non-uniform charging happens in each and every cell. So certain cells, say example, cell number 1, 10, 20, 50 or 75 or 76 or something, right? So certain cells being overheated because of it is having a higher charge. And say example, cell numbers 2, 7, 5, right, 175, 180 kind of thing, right? So we monitor each and every cells, right, for their charge, the state of charge, what we call as an SOC. So based on this SOC, the individual cells being given opportunity to charge. So make it uniform cell charging for all the cells. So this is what, right, optimized charging strategy. So and new battery chemistries like alternate materials. So this is very important to enhance the user satisfaction because there won't be any explosion, and the lifetime will also be more as expected. Enhance energy storage. So the solid state batteries can achieve energy densities over 500 watt-hour per liter, and significantly improving the range and efficiency of electric vehicles compared to traditional lithium-ion batteries. It goes for improved safety features. The use of solid electrolytes reduces the flammability and leakage risk, enhancing the safety profile of energy storage systems, particularly in electric vehicles. Then you have a sustainability potential of contributing to the sustainable manufacturing process by extending lifespan and reducing the waste, aligning with the global environmental goals in energy storage solutions. So the solid state batteries are recommended for the future. Then higher energy density and the safeties, because as we discussed earlier, when you are planning for the higher energy density, then always the safety risks are associated with this. Solid state batteries can achieve energy densities exceeding 500 watt-hour per kg, enabling longer ranges for electric vehicles and enhancing the efficiency of portable electronic devices. The non-flammable solid electrolytes in solid state batteries greatly reduce the risk of thermal runaway and short circuits, making them safer alternative for various energy storage applications. Then there are challenges in the scalability, the manufacturing process complexity. The transitioning to solid state battery production requires new manufacturing techniques and facilities. posing significant economic and logistical challenges for the scalability. Then material durability issues. The brittleness of advanced solid electrolytes can lead to mechanical failures, necessitating ongoing research to develop more resilient materials for reliable battery performance. So again, the material science research is important to prevent the mechanical failure during its operation. Then supply chain vulnerabilities. Fluctuations in the availability of critical materials such as lithium can disrupt production and consistency impact the overall scalability of solid state battery technology. So the mainly the lithium availability and the mining, then the supply chain, right? So we have to ensure that the raw materials are available so that this can be sustainable. And diverse battery technologies. The electric vehicle sector is increasingly adopting various battery technologies, including lithium-ion, solid-state, and sodium-ion batteries, each offering unique advantages in energy density, safety, and cost-effectiveness. And sodium is abundant and inexpensive, reducing the overall battery production cost. And sodium-ion batteries currently exhibit a lower energy density compared to lithium-ion alternatives. And increasing demand for sustainable energy solutions enhances the sodium-ion battery adoption potential. And establishing lithium-ion technologies pose significant market entry challenges for sodium-ion batteries. So now again, it talks about the materials aspect, whether we got to go with lithium or sodium-ion battery. So you have benefits and limitations for each and every material. The widespread availability of sodium derived from common salt significantly lowers production cost for sodium-ion batteries, making them an economically viable option for energy storage solutions. And sodium-ion batteries demonstrate enhanced safety features, including lower sensitivity to temperature changes and reduced risk of thermal runaway, posing them as a safer alternative for various applications. So when you compare this lithium-ion battery, sodium is more safe because it is having lower sensitivity to temperature changes and reduced risk of thermal runaway and explosion. In innovative battery materials, so research is focused on developing new materials that enhance energy density, safety, and sustainability, addressing the evolution of the energy storage technology. The advanced manufacturing techniques efforts are underway to create scalable production methods for next generation batteries, ensuring consistency and quality in manufacturing process. Then the recent integration of AI technologies, the application of AI, artificial intelligence, in battery management system is being explored to optimize the battery performance, charging efficiency, and life cycle management. So the role of AI is crucial nowadays because this can prevent the overheating based on the input conditions. Then it is helpful in prevention of explosions. Then alternate technology is related to the flow batteries. It has a long cycle life. The design of flow batteries allows over 10,000 charge and discharge cycle, significantly extending their operational lifespan compared to the traditional batteries. You have a scalability advantage because flow batteries can be easily scaled by adjusting the electrolytic volume and making them suitable for diverse energy storage needs in renewable energy systems. And these batteries utilize abundant materials, reducing ecological footprints and promoting sustainability energy solutions in grid storage applications. You have a vanadium redox flow batteries. You have a energy storage flexibility. So this VRFBs allows for independent scaling of energy, capacity, and power output, enabling tailored solution for various applications from renewable energy integration to grid stability. You have an environmental sustainability. So the use of vanadium, which can be recycled and is less geopolitically constrained than lithium or cobalt, enhances the sustainability profile of VRFBs in energy storage. And you have a enhanced safety features like this is non-flammable nature of vanadium and aqueous electrolyte significantly reduce the risk associated with thermal runaway, making this vanadium redox flow batteries a safer alternative to the conventional battery technologies. Then you have an alternate option like zinc ion flow batteries for grid storage. Then modular design benefits. You have a modular design of zinc ion flow batteries allow for flexible scaling of energy capacity, enabling efficient adoption to varying energy demands and facilitating integration to existing grid infrastructures for enhanced renewable energy utilization. And the emerging technologies involve the graphene battery innovations. And these graphene-based batteries promote and promise significant improvements in energy density and charge rates, potentially revolutionizing energy storage for electric vehicles and portable electronics through enhanced conductivity and lightweight properties. And bio-inspired energy solutions, you have emerging bio-inspired materials like so they mimic the natural process to improve battery efficiency and sustainability, offering innovative pathways for energy storage that align with ecological principles and reduce environmental impact. And revolutionary charge times. The graphene-based batteries are superior electrical conductivity, which allows for ultra-fast charging capabilities, significantly reducing the time required to charge batteries, which is crucial for consumer electronics and electric vehicles. Lightweight energy solution, as I said, the batteries are playing a major role in EVs, especially when the weight is been concerned, it is very heavy weight. So now we are moving towards the lightweight energy solutions. The lightweight nature of graphene-based batteries contribute to overall weight reduction in applications like electric vehicles because when you increase the weight of the vehicle, which causes more resistance to movement, which causes for reducing the range. So the lightweight batteries will definitely support for high range operations. This is also enhancing the efficiency and performance while maintaining the high energy storage capacity. Then sustainable material integration. The ongoing research focuses on combining graphene with sustainable materials, aiming to create eco-friendly battery solutions that minimize environmental impact while maximizing the performance and longevity. And cost efficiency of the materials with the magnesium and aluminum batteries. So it's an alternate. Magnesium and aluminum are abundant, reducing production costs and making these batteries economically viable for large-scale applications. Utilizing magnesium and aluminum minimizes reliance on scarce materials, promoting sustainable practices in battery manufacturing and disposal. And a lot of research are ongoing in electrolytes and electrode materials aims to enhance performance, addressing current limitations and paving the way for commercial viability. Then bio-inspired battery components. So these are development of biodegradable materials for battery component, reduces the environmental impact, promoting a circular economy and minimizing waste in energy storage solutions. So natural energy storage mechanism like research into biological systems reveals innovative energy storage methods, enhancing battery efficiency and sustainable through nature-inspired design and materials. And future advancement in bio-inspired batteries require collaboration across disciplines, integrating insight from biology, material science, and environmental studies to drive innovation. So today's development, we use artificial intelligence for many applications. And this is applicable for battery advancement also. The machine learning for predictive maintenance with the help of data-driven insights The machine learning enhances predictive maintenance by analyzing the vast data sets from battery systems, enabling accurate failure predictions and optimizing maintenance schedules, ultimately improving reliability and extending the operational lifespan of batteries. So earlier, right, there are two kinds of maintenance where in practice. One is the preventive maintenance and another is the failure maintenance or breakdown maintenance. So when it comes to the preventive maintenance, so it's all based on the time frame. Say example, so they fix a time frame of about number of hours of operation or the number of cycles or the specific duration in days or months or year, right? So these are all right. So based on the time frames. But now the concept is completely different. So now we use sensors to get data, various data like the conditions of the systems, like when it comes to the batteries, like the temperature, the number of cycles, then material being monitored, and how many times the overheating has done. So all those rights, the data sets are being used for analyzing the performance of the battery, so that before the failure happens, right? So the artificial intelligence, the AI will give a warning sign like this reached the number of cycles or this many times, right? The overheating happens for a particular cell. So this gives right warning, so that before the failure happens, the system is shut down for maintenance. So today, right, we depend on artificial intelligence because based on the inputs given to the AI, so more and more training given to the artificial intelligence, right? Then it is being trained for prediction in a more effective manner. So the output or the expectations are mainly based on the training. How do you train this AI? So that's what, right? Based on the available data sets and outputs available. So this is an input to the AI, so that once it has been trained, so before the failure happens, this gives the prediction. So smart battery management system is BMS. Admin, can you please mute participants? Yeah, thank you. So when it comes to the battery management systems, we make it more smart, what we call real-time monitoring capabilities. So you have a smart BMS continuously track critical parameters such as voltage, current, temperature, which is ensuring the immediate detection of anomalies and facilitating timely interventions to prevent potential failures. So the major information what you focus is on the voltage, current, and temperature. So okay, these are the crucial factors being obtained. So this has been monitored continuously. Then adaptive charging strategies like utilizing this AI algorithms, the smart BMS optimized charging process based on real-time usage patterns, enhancing energy efficiency and prolonging battery life through tailored charge and discharge cycles. So this is what I said. In earlier cases, this kind of dynamic system or adaptive systems were not there because it's all time-bound activity. So preventive maintenance is mainly based on the time frame. But now we monitor and we get the data, and based on this data, we go for adapting charge strategies so that the charging and discharging being optimized. With the AI algorithms, this leverage historical data to forecast battery performance, enabling proactive adjustments that enhance energy efficiency and extend the operational lifespan of energy storage systems. And intelligent load management. So by analyzing the real-time energy consumption patterns, this AI optimizes the load distribution across battery systems, ensuring efficient energy use and minimizing waste during peak periods. And this has been integration with smart grids. So AI facilitates seamless integration of battery systems with smart grids, allowing for dynamic energy exchange and improved management of renewable energy sources, ultimately enhancing the overall system efficiency. I think there are some noise. Admin, please put on mute to the participants. Akbar Hussain, yeah. Okay, thank you. In industry applications of advanced batteries, the electric vehicle innovations. So advanced batteries enable rapid charging and increased range, addressing consumer concerns and promoting adoption of electric vehicles in sustainable transportation. Then energy storage systems use advanced battery stabilize the grid by storing excess renewable energy, enhancing reliability and facilitating cleaner energy integration. So this is what the need of the hour, because we are not supposed to use the fossil fuels for charging the batteries. We have to rely on the renewable energy. So we have to go for smart grids. So you produce the energy from renewables, give it to the grid. So that, right? So the integration happens, right? So which reduces for more green energy utilization. Consumer electronics evolution. So compact, high density batteries power wearables devices and IoT application driving innovation and extending usage times while maintaining efficiency and connectivity. So when the batteries are being concerned, not only the electric vehicle batteries, so many applications, even the small batteries are necessary, like compact batteries for powering you the mobile computer, right? And the electronic systems for standby operations. So such kind of thing, right? So we are going with the high density batteries, compact, and even today we have more wearables and IoT, right? So everything is being internet connected. So IoT, so internet linked operations are possible. So even your electric vehicles are connected to the automotive manufacturers control. So in case of any malfunctioning, so the automotive manufacturers is capable of getting those data, analyzing those data, and they give the warning to the customer on certain aspects, like these problems are happening in your EVs. So this is what I write. So for that only, this IoT is helpful in modern systems. So all are IoT integrated. So this is more need of the hour, like fast charging and long range operations, which is being accompanied or accomplished due to the advancement in battery chemistry, like lithium sulfur and lithium air. These promise higher energy densities and enabling longer driving ranges for electric vehicles on a single charge. So now we are claiming almost 300 to 500 kilometers per charge, which is possible with this kind of techniques. Then integration of AI technologies, the AI-driven battery management system optimized charging cycles and energy distribution, enhancing overall battery performance and extending the operational lifespan of EV batteries. And development of the charging networks, expansion of ultra-fast charging networks is crucial for reducing the range anxiety, facilitating quicker charging times and promoting widespread adoption of the electric vehicles. So this is one of the major concerns, because consumers are always right to have an anxiety of range. So now fast charging networks, right? So this is under construction. So maybe after some 5 to 10 years of time, I think you will have a more number of right commercial charging stations. So grid level integration. So this is very important as energy storage systems are essential for balancing the supply and demand in renewable energy. So always, right, the demand will get increased with the more and more introduction of the electric vehicles. And the supply is always limited. So now we have to, right, go for balancing of supply and demand with the help of this renewable energy. This enabling the capture of excess generation and providing reliable power during shortages, thus enhancing the grid stability and reducing fossil fuel dependence. So now, when it comes to the compact batteries, so energy density innovations. So on-way research focus on enhancing the energy density through the novel materials, enabling long-lasting power solutions for compact wearable devices and IoT applications, and flexible battery designs, which allows the integration into diverse form factors, accommodating the unique shapes and size of modern wearable devices. Then sustainable battery solutions with the eco-friendly materials and recycling process. And lightweight and durable batteries are the most required thing. The aerospace and defense applications demand batteries that not only minimize weight, but also ensure high reliability under extreme conditions like the temperatures are plus 50 and minus 50. So almost it varies from right about 100 degree variations. Then innovative material utilization. So exploration of advanced materials such as graphene and nanostructured composites is essential for developing batteries that achieve superior energy density while maintaining the durability and lightweight characteristics. So as you are aware, right, the nano size materials are highly advantageous in many applications. The performance are good. It exhibits a very high strength, like CNT, right? The carbon nanotubes offers very high strength, even which is higher than the conventional or traditional steels. So we are working towards the innovative materials with the help of this nanotechnology. Then future research directions or the research focuses on enhancing battery technologies through interdisciplinary approaches, integrating material science and engineering, the artificial intelligence to overcome current limitations and achieve breakthrough performance in energy storage. And this is a transition to green battery materials. The ongoing research into alternate materials such as lithium sulfur and solid state technology aims to enhance energy density and safety, driving the next generation of sustainable batteries. Then policy and regulations impact. Already we have discussed about the government policies that promoting the green technologies and sustainable practices are crucial for accelerating the adoption of green battery materials, influencing industry standards and consumer behavior towards eco-friendly solutions. Then advancements beyond lithium, you have options like magnesium, zinc, etc. These are all abundant and reducing reliance on scarce resources and minimizing the environmental impact associated with the lithium extraction and processing. So now, right, people start working towards the alternates, like how we moved from the traditional fossil fuels like petrol and diesel into biodiesel and ethanol. Similarly, right, so lithium was the most reliable resource And now people are moving towards magnesium and zinc. So this both are exhibiting lower flammability risk compared to the lithium ion, which is more safer for operation. And ongoing research focus on optimizing these electrolytes and cathode materials for magnesium and zinc batteries, aiming to improve energy density and cycling stability for commercial viability. So here you could have observed the mainly they are working on the alternate materials where the battery is being manufactured, and the electrolytes and cathode materials for improving the energy density. So, and in addition to that, the safer and recyclable operations. So this is what the current research is moving. Then ultra fast charging technologies already we have discussed, and recycling and circular economic for batteries. Implementing a circular economy for batteries promote the recovery of valuable materials, reducing reliance on virgin resources and minimizing environmental degradation associated with the mining activities. So wherever possible, we have to go for recovery of the rare earth materials. Then effective battery recycling process significantly decrease the risk of toxic substance leaching into ecosystems, thereby protecting soil and water quality from hazardous waste associated with improper disposal. So the battery recycling methodology is in research. So we have to go for recycling of the materials. Then collaborative stakeholder engagement. So for successful circular economy initiatives require active participation from manufacturers, consumers, and policymakers, fostering a shared responsibility for sustainable battery life cycle management and recycling practice. So it's a combined effect of all, like starting from the manufacturers, consumers, and policymakers, right? So the policymakers are nothing but the government organizations where they formulate the committees. So they create the policy for each and every thing, so that for green environment, the safety and reuse or recyclable. So all those things been taken care by the policymakers. And it is for the consumers to go for proper selection of the batteries, and the manufacturers to use the advanced materials for the environmental benefits. Then cross-disciplinary research opportunities, because as we have discussed, these have many possibilities for the interdisciplinary or cross-disciplinary research, innovative material development. So collaborative efforts between material scientists and chemists can lead to breakthroughs in battery materials, enhancing the energy density and safety while addressing the limitations of current lithium-ion technologies. And this interdisciplinary research involving environmental scientists and battery technologies is crucial for creating effective recycling methods that minimize waste and recover valuable materials, promoting a circular economy in battery usage. And to conclude, the integration of AI in battery technologies is reshaping energy storage, enhancing efficiency, and driving innovation across multiple industries, including transportation and renewable energy. Then broader implications for the society. Advancement in AI-driven battery technologies are crucial for achieving sustainability goals, reducing carbon footprints, and facilitating the transition to cleaner energy sources globally. Then the future research directions are ongoing exploration of alternative materials. Recycling process is essential for sustainable battery development, addressing environmental concerns while improving the performance. The key takeaways from this session: the transformative AI integration The AI's role in battery technology is pivotal, enhancing design, manufacturing, and predictive maintenance, leading to improved performance and sustainability. Then cross-industry implications. The advancement in battery technology driven by AI have significant impacts across various sectors, including electric vehicles, renewable energy, and consumer electronics. Then future research necessities. The ongoing research is essential to explore AI's potential in battery innovations, focusing on sustainable materials and recycling process to address environmental challenges. Then potential societal technological impact. The integration of AI in battery technology significantly accelerates the transition to renewable energy sources, enhancing the grid stability and enabling communities to harness local energy resources effectively. Then job market transformations. As AI-driven battery innovations proliferate, the job markets will evolve, necessitate new skill sets in AI and energy management, thereby fostering a workforce adapt in emerging technologies. Then open questions for the research. You have a chemical interaction mechanism. So investigating the specific chemical interaction influenced by AI in battery materials is crucial for developing alternate chemists and enhancing the stability and performance of next generation batteries. Then data generation techniques like developing innovative methods for generating high quality synthetic data that accurately reflects real world battery conditions is essential for training the robust AI models and improving the predictive capabilities in battery research. And long-term predictive reliability, understanding the factors affecting the battery degradation over time and integrating these variables into AI models. This will enhance the accuracy of lifespan predictions and optimize maintenance strategies for battery systems. So collective contributions are recognized. The advancement in battery technology through AI are a testament to the collaborative efforts of researchers, industry partners, and regulatory bodies, whose combined expertise and support have been crucial in driving innovation and sustainability in energy storage solutions. So with this, thank you so much for your patient listening. It's an whole, right? So now we are moving towards the EVs. So when the EVs are concerned, then the adaptability is a bigger question. So how we adopt the EVs, then what are the challenges when we go with the adoption? Then what are the government policies and incentives for encouraging the customers to adopt the EV? So all those things are right in today's ongoing research. So this faculty development program will definitely throw an insight about the electric vehicle technologies and the adoption for the future. So with this, I'll conclude my session. Any questions are welcome. Thank you.
Yes, Professor, they are very useful research areas, but the status of India would be very important, sir.
Yeah.
So can you throw some light on that?
Can you repeat? I couldn't get your question.
Yeah. Can you throw some light on the Indian research side? Because all these areas are happening outside globally in very few countries. So what is it in the status of this research in India?
No, I couldn't get what is your expectation.
So what is it in India that is being researched?
Yeah. No, the thoughts I shared, right? So anyway, we have come to the adoption of EV, and the EV is available in the market. So for some more time, maybe another 10 years or 20 years, right? So this technology will exist. So in such case, now the research is moving towards the material science, because there are many aspects of material science, like starting from the automobile as a whole, the electric vehicles, the engine, the motors, the batteries, and all control systems everywhere, right? So everywhere, right? So we make all the system with the help of materials. So the material science is one of the area, and with the help of the artificial intelligence, we are able to predict the performance, right? How the material will behave. So this kind of work is essential in order to improve the performance of the existing system. So that's what when it comes to the battery technologies, we work on alternate materials, like we are moving away from lithium-ion batteries into alternate materials for enhancement of the performance, higher energy density, and higher safety. So this is what, right? When we go towards the alternate materials, then what will be the electrode and electrolyte combinations, and how about the charging and discharging cycle? And with artificial intelligence, we'll be able to predict the behavior of the batteries for improvement of the battery performance, right? So this will be in practice in future for some more time. So till this technology exists, and there are many countries, they are moving away from battery vehicles, because batteries are highly polluting the environment, because when lithium is concerned, lithium production or manufacturing of lithium ion consumes more energy comparing to the petroleum fuels. So it starts from the mining and processing and battery manufacturing. So everything consumes a lot of energy than what it's having the energy content. So it is not advantageous to go with battery technology. Instead, people are working towards the hydrogen energy technologies, where hydrogen can be directly used in IC engine, or it can be used as a hydrogen fuel cell. So the future may change, right? But for the time being, these batteries are surviving. But we always, right, work towards the betterment for the environmental aspect. So this battery technology will be there for some more time, and definitely it is going to be obsolete after some time, as how this IC engine and alternative fuels or the fossil fuels have come to an end.
Absolutely right. So we will have to have what is called as a top-down approach to have a balance between the battery technology, the alternative fuel cells, and the environment, financials, and the time. So it is about 20-25 years from now that we can safely say that something new will come.
Yeah, definitely.
And will be adopted.
Yeah.
So as of now, everything that you have spoken, the challenges or the future things. So that is a very good game. I can say as a game. It can be a 4x4 game. It can be a 6x6 game to understand what would be the best of it.
Yeah.
Thank you very much. Thank you.
Okay, now we have come to the end of the session. So if any more questions, you are free to post it. So I am happy to answer by reply, okay, through the coordinator.
Participants, is there any queries?
Sir,
Is there any queries from participant side? Any clarification, any doubt?
sir, am I audible, sir?
Yes, you are audible.
I am audible, yes.
Sir, you said the research is going on with magnesium and zinc-based batteries. What is the characteristics and cost-wise difference between lithium-ion and magnesium and zinc-based batteries, sir?
So you want to know the cost, right?
Cost and characteristic difference.
Yeah, cost and characteristics. Actually, this lithium is costly, and manufacturing of lithium creates a lot of pollution. So that's why we are moving away from lithium. So the alternate materials are relatively cheaper, and we have abundant resource and non-combustible, right? Or it is not so sensitive to temperature. So these are all the advantages. That's why we are moving away with lithium.
Okay, sir. Thank you, sir.
Yeah, Dr. S.V. Saravanan, you are on mute. Please unmute and speak.
Yes, sir.
Yeah.
Dr. Jamuna madam, is it okay?
Yes, sir, I got the answer, sir.
Okay, thank you. Thank you. Thank you for your
Thank you.
clarification. Participants, if there are no queries, shall we move on to the Thanksgiving session? Participants, now floor is open for a discussion. Professor Dr. Arul Selvan,
Yeah.
a lot of participants, they are posting their Thanksgiving messages to you. Highly informative session, sir. Thank you. The session was very useful. Can you please share the PPT? PPT will be given. Participants, don't worry. Thank you, sir. Thank you very much, sir. We got very much insights of battery management. Thank you, sir. It is very much useful session. Okay. Participants, if there are no more queries, can we move on to the last part of this today's presentation? That is Thanksgiving session. Okay. Professor,
Yeah.
there are no queries because you have explained all the queries from all the participants. Now we will move on to the Thanksgiving session. Thank you very much, Dr. Arul Selvan, sir. 2 sessions continuously right from 6 p.m. to 9 p.m. You have given very good lucid presentation and your practical approach and various insights of government policies and norms. You have explained in a very nice manner. Thank you very much for accepting our invitation in a short notice, and also in spite of our busy schedule, you have accepted and responded to the invitation very well. On behalf of the AICTE New Delhi, the ATAL Online FDP scheme, and on behalf of our own management, Meenachi Sundararajan Engineering College Autonomous Institution, Kodambakam, Chennai, on behalf of Mechanical Engineering Department, on behalf of my co-coordinator, Dr. Vijayan, and principal and myself, the coordinator of the ATAL FDP program, Dr. Saravanan, we express a heartfelt thanks to you for giving the various insight to the participants. More than 157 right now. Today they have participated, though the registered participants are 257. Thank you very much, Professor. Very kind of you.
Oh, thank you, Professor. Thank you for giving this opportunity to meet the faculties national level. So it's a very great opportunity, and definitely this will throw a light on the faculty and researchers to think. Okay, the scope for doing research related to material science and batteries. So with this, I'll conclude my session. And if you have any queries, I'm very happy to answer through your coordinator. So thank you very much for your patience listening. So thank you all.
Thank you, Professor. Jai Hind.
Jai Hind. Thank you. Shall I leave now?
Yes, Professor. Yes, Professor.
Yeah, thank you.
Participants, thanks for your attendance today and feedback. Wish you all very happy good night. Thank you.
Thank you, sir. Good night, sir.
Good night, sir. Night. I really, speaker has made this a wonderful presentation today. I hope participants has got the various insight in this battery management in session 4 and in session 3, the government policies. A request from the coordinator side. All of you kindly fill the attendance sheet and feedback form. Participants, do you facing any difficulty in Google form for attendance and feedback for today's session? Please let me know. Sir, they're asking feedback link, sir. Feedback link already posted. Please check. Both in the chat box and as well as in our participants WhatsApp group. See that link, Google link it's a 2-in-1, both for attendance and as well as feedback. There is not any two different sheets posted. Only one link has been posted as usual yesterday. That is will be counted for attendance and feedback. Mhm. Thank you, participants. We have received your attendance and feedback. Tomorrow, please log in by 5:45 p.m. Same login ID and passcode. And sharply by 6 p.m. session will be starting. Thank you very much. Good night.
Thank you, sir.